Feedback for week 3. Here's some things I want to talk about that I think a lot of people would benefit from. So first, how to multiply fractions. It's not scary. It's not that bad. It's going to blow your mind if you don't know it already. I say it all the time. So here it is. You multiply by the top and divide by the bottom. That's it. And that makes sense because what is this saying? It's saying 6 times 5. And then it says divide by 3. And of course, we can do that in any order we want because this is all one term, right? There's no pluses or minuses here. So again, we're timesing by 5. And then at some point, we're supposed to divide by 3. So it doesn't matter what order we do it in. For this one, you could times by the top and get 30. And then we're supposed to take 30 and divide it by 3, which of course is 10. You could have also divided first. First, we do 6 divided by 3 and get 2. And then I'm supposed to times by 5, which of course is also 10. Now, fractions don't always come out nicely like this. It did because I have a nice divisor on the bottom. If I had something like a 7 on the bottom, I would probably not want to divide first, but I could times first and get 30 and then divide it by 7. And before you go grabbing a calculator, figure out what that is, this is the answer. 30/7 is the answer. Fractions are division for lazy people. So if you're too lazy to divide 30 by 7, like I am, and get a decimal that you might have to round, instead what you can do is just leave it in a fraction, and it's perfectly acceptable. In fact, it's an exact answer. It is a better answer. Higher level math, we prefer improper fractions over decimals. All right. The next thing I want to talk about is some multiplication ideas. Like how to multiply a number like 6 times 16. Don't do it like this. This is slow. It requires you to remember this number in your head up here, right? While you do it, and then you get 6, 3, 96. Instead, do it reverse. Do 6 times 10, because that's what that 1 stands for, which is 60. And 6 times 6, which is 36. 96. Same thing with 7 times 14. 7 times 10 is 70. 7 times 4 is 28. So it looks like we're getting 98 out of that. So that is 98. 26 times 7. Another example. 20 times 7. Remember, we're doing 20 because that's what that 2 stands for, right? 20 times 7 is 140. And then 7 times 6 is 42. So 182. What this is going to come out to. 321 times 8. 300 times 8. Well, 3 times 8 is 24, so 300 times 8 is 2400. Again, my logic here is 300 times 8, right? So 3 times 8 is 24, so 300 times 8 is 2400, right? So 2400. And then 20 times 8 is 160. And 8 times 1 is 8. So if I add up from the back, looks like I get 8. 10's place, I have 6, so a 60. And then I have 100 plus 400, which is 500. And then I have 2,000. So 2,568. Start doing math that way, break things down. The big concept that we're doing here, the idea of this and why it works, is that 60 times 16 is just saying I have 16 sixes, right? I have 16 of them. So I can think I have 10 sixes and I have 6 sixes, right? For a total of 16 sixes. So 60 is what this is, and this is 36. So in total, I have 96 ones. So 16 sixes is just 10 sixes plus 6 sixes. Start thinking like that, you'll be much better at math, not just this stuff, but like actual math. Then one last thing I want to talk about, talking about roots as we finish up our pre-algebra unit. The first one I want to talk about is the root of 256. So square roots are not division, right? We're not dividing this by 2, but we are thinking what number times itself gets this. Now, you might not know off the top of your head what times itself is 256, right? So you might not know the answer immediately. That's fine. We need to have a strategy for when we don't know the answer immediately, because as problems get harder, no one will know the answer immediately, right? So maybe you do know this one, but if you don't, that's fine. That's great. So what we can do is we can think about this problem differently. Instead of thinking of it as 256, we can think of it as maybe 2 times something. So here's where what we were just talking about kind of comes in handy. I can think about 2 times what gets me 200, well, 100, right? And 2 times what gets me 50, 25. And 2 times what gets me 6, 3. So I've got 100, 25, and 3, right? So 125 plus 3 is 128. So 2 times all of this will get me 256. And we can check that using multiplication like we just did earlier. 2 times 100 is 200. 2 times 20 is 40, which isn't right, but 2 times 8 is 16. So 40 and 16 will make 56. Well, I can also think of this as 2 times 2 times whatever this is, half of that, because, right, this guy's even, so I can take out a 2 from it, right? I can divide it by 2 or think of it as 2 times something. 2 times what? Well, 2 times 50 is 100. 2 times 10 is 20, so we have 50 plus 10, that's 60. And then we have 4, right? So we have 64. So right away, you can see that this is 4 times 64. This number is the same thing as 4 times 64. Well, I know what the root of 4 is, right? Once I get to a point where I can take roots of my numbers, I should start doing that. So the root of 4 I know, that's 2. And the root of 64 I also know, that's 8. So in total, 16. That's what this will equal, right? So I couldn't root the whole thing. So what I did is I broke it down by multiplication. I kept it all one term, right? I'm not using addition or subtraction here. And so now I can root the individual factors of 256. So this one comes out nicely. We call this a rational solution because it comes out to a number that doesn't go on forever as a decimal and doesn't repeat. But there are other ones that don't come out that way. Let's take a look at this next one. The next one I want to look at is the root of 200. This does not come out nicely, but we can apply the same logic. If we think of 200 as 2 times 100, and you can always take out a 2 whenever it's even, right? That's an even number because it ends in an even number, 0, 2, 4, 6, 8, right? I think it's 2 times 100. Well, I know the root of 100 is 10, right? So I'll just take the root right now. But the root of 2 doesn't come out nicely, and I can't break down 2 anymore, right? 2 is a prime number, right? There's no way I can break that down other than 2 times 1, right? So I can't break down 2 anymore, so I just leave it like this. So we have 10 times the root of 2, or as we say often, 10 root 2. That's what this simplifies to, 10 root 2. So it's root 2 times 10 is the same thing as the root of 200. This is an irrational solution because if you were to plug this into a calculator, this would come out to be a decimal, right? It would be a little bit more than 10, actually it'd be more than 10, it'd be more like 2. Really close to 2, right? And would go on forever with no pattern. So this is a rational solution, comes out nicely, right? Even if it's a fraction, like 1/3, that would be rational because we can write it as a fraction, right? This we cannot write as a fraction because we have this root symbol here and this comes out nasty. So we call it irrational. The next one I want to take a look at is this one, the root of 342. Again, it's an even number, so I can take out a 2. Half of 300. Well, if you don't know that, right, because it's kind of weird, it's like an odd number. Half of 200 is 100, right? Half of 400 is 200. So it's got to be somewhere in between. Let me say that again. So 200 is 100 times 2. And 400 is 200 times 2. So 300 should be something between 100 and 200 times 2. It's going to be 150. Right in the middle of 100 and 200. Because if we double 100, we get 200. And if we double 50, we get 100. So 200 plus 50, or 200, let me say it again. 200, doubling 100, right? You get 200 times, or plus 100. God, let me say it one more time. 2 times 100 is 100, 200. 2 times 50 is 100. So 200 plus 100 is 300. There we go. Oh, man, made that more complicated than it had to be. So 2 times 150 gets me 300. If you need to, you can write that down. 2 times 20 gets me 40. And 2 times 1 gets me 2. So it looks like if I double 150, I get 300. If I double 20, I get 40. If I double 1, I get 2. So 2 times 171 gets me 342. Now you might notice that 171, this number right here, is odd. So we can't take a 2 out of it. So we might have to guess and think, can I take anything out of this, right? Is it divisible by something? And there's a trick for 3s. So 2s we know because they end in an even number, right? We know we can take out a 2, right? If it ends in an 8, a 6, a 4, a 0, or a 2. But if it ends in not an even number, then we can't take out a 2. But we might be able to take out a 3. That's the next one we should check. And the way you can do this is you add up all the digits. 1 plus 7 plus 1. And if you get a number that's divisible by 3, like this one is 9, when you add them all up, 1 plus 7 plus 1 is 9, then you can divide it by 3. So I'm going to write it as 3 times something. Well, 3 times what, right? Well, I don't know how many times 3 goes into 171, but I do know 3 times 33 is 99. So that gets me sort of close, right? 99 is sort of close to 171. It's 72 away, right? So the question is, how many times does 3 go into 72? Because altogether, that's going to get me 171. So I can figure those out. I win. Well, I know let me say that again. I know that 3 times 20 is 60, right? So 21 is 63. 22 is 66. 3 times 23 is 69. Nice. And 3 times 24 must be 72. So altogether, it's 3 times 57. That's going to get me that. So I can rethink of this as that. Well, I don't know the root of any of these. Can 3 go into 57? It can, because 5 plus 7 is 12. And 12 is divisible by 3. So it looks like 2 times 3 times 3 times something is going to be 57, right? 3 times something is 57. Well, I know 3 times 20 is 60, right? So 57 is just 3 away from 60. So it looks like I need 1 less 3. I only need 19 3s to get to 57, whereas I need 20 3s to get to 60. So I'm going to get 19. Now, I know 19 is a prime number. I can't divide anything out of that. And you'll notice what I have here is 9, right? So what's the root of 9? The square root of 9 is 3. And what's left over is 2 and 19, neither of which I can take anything out of. So I'm just going to multiply those together. 2 times 20, if that was a 20, 2 times 20 is 40, right? So 2 times 19 is 38. So this simplifies to 3 times the root of 38, or 3 root 38. That's what this is right here. So we took out as much as we could. If you run into an odd number, that doesn't mean you're stuck. You need to think, do other numbers go into it? And a good one to check is 3. And again, the idea is you can add up those digits, right, and check. So 342. And the last one I want to do, sticking with square roots, we'll talk about cube roots and all that other stuff some other day, but 18432, square root of that. Well, we know it's even because it ends in a 2. So I can write it as 2 times something. Now, instead of thinking about how many times it goes into 10,000, I'm going to go how many times it goes into 18,000. So 2 times 9,000 is 18,000. So we got 9,000. In fact, I'll write it down here. 2 times what is 400? Well, 200. And instead of thinking 2 times 30, I'll think what times 2 gets me 32, right? Because I know that one. It's 16. So when I put these together, I get 9216, which of course I can rewrite as 2 times something. So I'll keep the 2 I had before. 2 times what is 9216? Well, I know 1,000 is 500, right? 2 times 500 is 1,000, and 2 times 400 is 8,000. So it's got to be between 4 and 500. So it's gonna be 450. So I got 4500. 4,500. So 2 times 4,500 gets me 9,000. Half of 216. Well, that one I can actually do in my head really easily. That is 108. So it looks like all together I'm going to get 4608. If I double all that, I'll get 9216. I can keep going, right? I can take out more 2s. So I'm going to write, well, first off, actually, this 2 squared, when I root it, just becomes 2. Right? 2 squared which is 4. 4 rooted becomes 2. So I can write this as 2 times 2,304. That one wasn't so bad. Right, double 2,000, double 300, double 4, we get this. So I can write that again as 2 times 2 times something. Looks like 1,152. So this gets a 2 out. So now I've got this, right? 4 rooted is 2, so I have 2 2's out here. So what's left over is 2 times whatever this is. Looks like 550 plus 26. So 576. If I keep going, I can take out another 2. In fact, I'll simplify that to 4. 2 times 2 is just 4. So if I take out another 2, I'm left with 250, that's half of 500, 35, so that's 285, and half of 6 is 3, so 288. Of course, when I root 4, I get another 2, so now I have an 8 out here, right? 2 times 4 is going to get me 8. Out here, I can do 2 times 144, and that'll equal 288. And I know what the root of 144 is. It's 12. So on the outside, I have 8 times 12, and on the inside, I have root 2, because I can't simplify that anymore. Applying what we learned earlier with multiplication, I can see this as 80 plus 8 times 2, which is 16. So 80 plus 16 is 96. So 96 times the root of 2 is what this simplifies to. All right, and that's it for this week.